In this video, we're going to talk about the Excel solution for the transportation problem in the slides. At the bottom right of this spreadsheet, you can see the actual network. So we have 3 suppliers, Kansas City, Omaha, and Des Moines. There are 3 customers, Chicago, St. Louis, and Cincinnati. The 3 suppliers have IDs being 1, 2, and 3. 3 customers, the IDs are A, B, and C. So I have the labels on those arcs in the green box showing the unit shipping costs for the arcs, right? For example, to ship 1 ton of wheat from number 1 Kansas City to C Cincinnati, it costs $10. And we have the supply numbers for each supplier in the red box, the demand numbers in the blue box for each customer. On the left, we have a gray box that shows the mathematical model that we created for this network. So the variables are defined for each arc, ij, right? So we have 2 subscripts, I denoting, the first subscript I denoting the supplier, the second subscript j denoting the customer. For example, x2a shows the amount of wheat shipped from to Omaha to a Chicago, right? And it costs $7 per ton. So if we multiply 7 with the volume, that is the amount of wheat, this will give us the cost associated for this route or this arc, right? To compute the total shipping cost, of course, we're going to do the multiplication for, in this case, 9 times, right? By multiplying the labels with the associated variables for those arcs, and then we do a sum. This will give us the total cost. The constraints are with regard to the supply and the demand. For each supplier, the amount of wheat being shipped out of it should be equal to what it has, right? Because again, this is a balanced problem. So we have total supply equals total demand. So we have equations or equalities for the constraints. Right? So whatever is shipped out of Kansas City should be equal to 150. Whatever is shipped out of Omaha should be equal to 175. Right? To calculate the out, right, we do a sum over the 3 variables associated with the 3 outgoing arcs. Right? So from Kansas City, 1 to Chicago, which is A, right? So X1A. From Kansas City to St. Louis would be X1B. Kansas City to Cincinnati, X1C. So we have X1B plus X1C plus X1B, right, on the left. And on the right-hand side of the equation, we have 150, which is the supply. Right? Same thing for Omaha and Des Moines. For customers, we look at the incoming arcs. As an example, for Chicago, there are 3 incoming arcs. In other words, Chicago can receive the wheat from 1 Kansas City, 2 Omaha, and 3 Des Moines. Right? So whatever is received by Chicago should equal to what it wants. Right? That is 200. So X1A plus 2A plus 3A should be equal to 200. That's what we have here. Same thing for St. Louis and Cincinnati. The top half of this spreadsheet shows 2 separate tables. Right? The one on the right shows the shipping cost. There's in dollars per ton. So that's the unit shipping cost, which are given as parameters. So they're constant numbers. There's simply the labels on those arcs, right? So $11 to ship 1 ton of wheat from Omaha to St. Louis, $12 from Des Moines to Cincinnati, and so on. And on the left, right, we have a similar table, but they are used to store the variable values. Right? So for each blue cell corresponds to a variable. Right? For example, here, this will be X1A, right? Because the ID for Kansas City is 1. right? And Chicago has A as the ID. So this is X1A. This will be X3C, right? Because Des Moines has 3 as the ID and Cincinnati is C, right? So this is X3C. Similarly, we can see that all the blue cells, right, they are actually a direct representation or implementation, okay, of the 9 variables, right, that we defined in the mathematical model, right? For the orange cell, we're going to calculate the objective function. Right. The objective function is simply, as we discussed earlier, right, the labels on those arcs, which are stored in this table on the right, some product with the blue cells, which are the variables, right? So here we just need to do some product. Take 2 parameters, right, the variables and the coefficients. Okay. So these are the variables, and these are the coefficients. Right, so this will be the, this formula will calculate the total shipping cost. Okay, and then let's look at the constraints. Again, so there are 2 types of constraints for the suppliers and for the customers. But for both of them, as you can see, they're just the sum of some variables, right? So the 3 yellow cells in column F will be used to store or to implement the left-hand side of the 3 supply constraints. Right? So essentially here we want to do a sum, okay, over x1a, 1b, and 1c. Right? So this is x1a, this is x1b, this is x1c. So we just need to add them together. Right? Same thing for the cell F6 and F7. So we just need to do a sum over the 3 blue cells that are on the left of the yellow cell. Right? So I think I can just copy and paste it here. Right? So this is C6 through E6, C7 through E7. Right? And the 3 yellow cells in row number 8 will be used to implement the left-hand side of the customer constraints or the demand constraints, right? So again, they're just the sum of 3 variables, right? So 1a, 2a, and 3a. So this is 1a, this is 2a, this is 3a. So essentially, we just need to do a sum over the 3 variables or the 3 blue cells that are above the yellow cell. Right? Same thing here. So sum of the 3 blue cells that are above the yellow cell. Okay. And all the uncolored cells in this table on the left, it shows some extra information, including some text that help us understand the cells, right? And also the supply and the demand numbers. So they will be used when we're adding the constraint to the solver. Okay, so once we finish putting those formulas in the yellow and orange boxes or cells, right, we can go to the solver. Right, we just need to go to the data tab. Oops. First, you have to make sure that you have the solver plugin installed, right? Then click on solver. Okay. The objective is the orange cell, and we're minimizing the shipping cost. So the variable cells are the blue ones. The constraints, again, there are 2 sets of constraints. So first, the supply, it should be equal to the available. Okay, and the second one is for the customers. So they should be, the yellow cell should be equal to the demand. Okay, and we have to check this box. right, to make sure that all the variables are non-negative, and then we select simplex LP, right? And we click on solve. And here we can keep the solution. So this will be the optimal solution. And the optimal cost will be $4,525.